Okay, so we've spent the last couple of days looking at arithmetic sequences. Today we're going to focus on geometric sequences. Arithmetic and geometric sequences have similarities, but of course they have differences. Otherwise there'd be no point in studying them if they were exactly the same. The major difference between the two is that whereas in an arithmetic sequence, to find the terms, we're going to be adding or subtracting some value, which we call the common difference. In a geometric sequence, you find the value between the two terms in the form of a ratio. And the difference by which the sequence changes is called the common ratio. So we're going to find that difference, except it's not a difference, but that suggests subtraction. Instead, it's going to be multiplication. And you'll see how we do it in just a minute. Underneath the two vocabulary terms are the same two formulas we use for an arithmetic sequence. A recursive definition, which is helpful to find the next term in a sequence. So if you have the third term and you're asked to find the fourth term, you would use the recursive definition. And then of course if you're looking for a term down the road, 9th term, 10th term, whatever, you use the explicit formula. But you'll find the way we go about doing these things is going to be the same. So if you understood arithmetic sequences, I don't expect that you will have difficulty with geometric sequences. Alright, so here's an example. First thing we want to do is we want to identify whether we're dealing with a geometric sequence and then identify what the common ratio is. So you can see that instead of adding, instead of subtracting the value of the second term from the value of the first term, we're going to go ahead and try to make a ratio. We're going to divide the value of the second term by the value of the first term. So if we do that here, we have the first two terms of 3 and 6. We do 6 divided by 3, which gives us 2. Go on to the next one. 12 divided by 6 gives us 2. 24 divided by 12, big surprise, gives us 2. And then 48 divided by 24, once again, 2. So because these values are identical, because we got 2 each time, yes, this is a geometric sequence, and the common ratio is 2. What a nice multiple choice question that would make. Is it a geometric sequence? Identify the common ratio. What do you think? No? Think again. Of course. Anything we cover in class is fair game for us. Good. I'm glad you think so. It's A's for everyone. Oh, good. Okay. Does anybody have any questions about this? All right, let's compare this one to another. What? Stop. All right, so if we look at this one, 3, 6, 9, 12, 15. Again, we do the same thing. We do 6 divided by 3, which coincidentally gives us 2, just like we did the first time. But here we have 9 divided by 6. 9 divided by 6, of course, is 1.5. As soon as you see that the numbers, the quotients are different, you can stop, because that tells us immediately that there is no common ratio, and therefore, no geometric sequence. Over here on the right side of the board is just a different looking example. Instead of having just numbers, we have exponents. The way we do the problem is the same. We take the second term, which is 3 to the 10th, divided by 3 to the 5th. Of course, you have to know your properties of exponents. What do you do to exponents when you divide and the bases are the same? You subtract is correct. So 10 minus 5 gives me 3 to the 5th. 15 minus 10 again gives me 3 to the 5th. And finally, 20 minus 15 gives me 3 to the 5th. So that is indeed a geometric sequence. So that's the first thing that you might be asked to do, is identify whether you have a geometric sequence. So I could actually ask this as one big problem. Is it a geometric sequence? Identify the common ratio, and then find the blah, blah, blah term. 9th term, 10th term, 14th term, whatever. Which is what we're going to do next.
Would you just like to find that?
Yeah. Is there anybody not ready? Everybody ready? Okay, let's proceed. All right, so you can see it's a two-step process, just like in an arithmetic sequence. So here we want to find the 10th term of this geometric sequence. Again, we don't have to first identify whether it's a sequence. We are told that. So we can go straight into finding the ratio. So to find the ratio, again, you can take any two consecutive terms. I personally try to keep it as simple as possible, so I use the smallest numbers I can find. To me, that's 12 and 4. Could you use 36 and 12? Of course you could. So here we get 12 divided by 4. I don't need a calculator to know that that answer is 3. So that 3 is the common ratio. And the abbreviation we use in the formula for the common ratio is R. Good formula for Pirate Day next September. Usually September. What's the common ratio? R. So now we want to find which number term. We want to find the 10th term. So we want, I'll write it over here. So a sub n is equal to a sub 1 times Rgn minus 1. We are looking for the 10th term. We want to know the value of a sub 10. What's our first term in this sequence? Not term 1. What is the value? 4. So it's 4 times our common ratio is 3. 3 to the 10 minus 1. So what I get is 4 times 3 to the 9th power. Since 3 to the 9th power is significantly more difficult than 12 divided by 4, I'm going to go to my calculator, and I'm going to do 3 to the 9th power is that. Multiply that by 4, I get my answer of 78,732. So a sub 10, 78,732.
What is the 10th term?
That's the number of the term that I'm solving for, the 10th term.
And that is ever going to change.
Of course it's going to change. Every problem is going to be different. You're not always going to be asked to find the 10th term. You could be asked to find the 8th term, or, as in this evening's homework, you might be asked to find the 8th term.
We said the 8th before, right?
On tonight's homework. The homework questions don't ask you to find the 10th term. They ask you to find the 8th term. The question was, is it always going to be the 10th term that you're looking for? The answer is no. Next thing is, just as in an arithmetic sequence we were asked to find missing terms, we can do so in a geometric sequence. And just as our two-step process was to find the common difference and then apply it, Here we're going to find the common ratio and then apply it. The difference comes in how we find the common ratio. Rather than using a separate equation to find the common difference, here we're going to use the same explicit formula that we just used. So in one respect, this is easier because it's one less formula to memorize. So we do need to know these two things, our first term and our fourth term. So the value of our first term is 2, and the value of our fourth term is negative 54. So that's what we're going to plug in here. We want our fourth term. Now instead of figuring out what this is, they're telling us what this is. It's negative 54 is equal to my first term, which is 2, times, here's where it differs, because now, instead of first finding the common ratio, we now have to solve it in the context of this equation. So we're going to have r to the n minus 1. Our n value was 4. 4 minus 1 is 3. Now I'm going to solve for r. So I'm going to divide both sides by 2. We get that r to the third is negative 27. Those of you not strong in your cubes can go to your calculators, find the cube root of 27. Those of you who are stronger, just know that the cube root of 27 is what? 9 times 3 is 27. We want what number raised to the third power. You actually could use a logarithm if you wanted to. That would really impress me. Can I give you a bonus point? Use some log. Anyway, and remember this is negative 27, so my ratio is actually negative 3. Now I go to step number 2, and just as finding the missing terms in an arithmetic sequence, I then added or subtracted my common difference. Here I'm going to multiply. So I to find the second term, I take my first term, which was 2, multiply it by negative 3, gives me my value of negative 6. To find the third term, I take my negative 6, and multiply it by negative 3, to give me positive 18. Don't get thrown off by the fact that one of your answers is negative and one of your answers is positive. If you look at the sequence, what do you notice about the terms? One of them is positive, the other one is negative. That tells you, or should tell you, that your answer is going to jump back and forth between negative and positive. Because really the only way to get a negative number as an answer is if one of the numbers you're multiplying by is a negative number. Still easy? Easy is in the eye of the beholder. What's easy to you is not easy to everyone else, and vice versa.
Vice versa.
Vice versa. I'm partial to it. See you later. We need such as like say one more bang of the light. What's the score? It's a word problem. Okay, so just like with arithmetic sequences, you can use geometric sequences to solve actual real-world situations. Here we are bouncing a ball from a height, and basically, when you drop a ball from a height, the height of the bounce will decrease geometrically. In other words, that the ball is moving at the same rate. It bounces a certain distance after the first bounce, and then less and less and less until eventually it stops bouncing. Okay, so we want to know how many centimeters the ball is going to bounce on the fourth and fifth bounces. But what I did is, just as I did with an arithmetic sequence, is I set up my very own private geometric sequence, which I'm going to share with you,
Wow.
because I'm just that generous. So there's my private geometric sequence that I myself created. You should do the same when you are faced with such a problem. And then I also jotted down the explicit formula because I need to find the common ratio. So now once we have our formula, we're going to plug in. So what do we know? We know a sub 1 is 100. So if I'm using 100 as my a sub 1, what goes here? 49 is the only other number that I have in the problem. I'm going to multiply that by r. I don't know what r is, that's what I'm figuring out. And then n, what was my n? What term number is 49?
There's
Trace, not tress.
I thought you said first.
3 minus 1 gives me 2. Thank you, Ms. Bilingual. So what I get is I get 149 equals 100 r squared. So I'm going to now solve for r just as I did before. So I'm going to divide both sides by 100. I get that r squared is equal to r squared is equal to 49 over 100, but I don't want r squared, I want r, so what do I have to do to both sides? Take the square root. So what I get is I get the square root of 49 over 100. Square root of 49 is 7. Square root of 100, 10. And then you'll probably want to convert it to a decimal because it'll be easier for you to use.
0.7.
Thank you, Jillian.
No problem.
7 over 10 can be converted to 0.7. That's my r. Now that I know the ratio, I can just plug it in. So to find my fourth term, it's going to be 49 times 0.7, which is 34.3. And then to find my fifth term, it's going to be 34.3 times 0.7, which the book tells me is approximately 24. And since we are talking about a real-world application, we must include units. So this is going to be centimeter here, and centimeter there. Here a centimeter, there a centimeter, everywhere a centimeter. And he was a terrible speller. Hold me up.
What?
Okay. Okay, does anybody have any commercial?
Yeah.
Does anybody have any questions? I have commercials on the brain. Anybody have any questions about this? Anybody not done copying? Speak now.
Did I get the weird pattern?
Yeah.
Yeah. Hi, future self.
Okay, the last thing that I want to talk about today is,
Oh, wait. Oh,
I asked if anybody was not done.
sorry, I wasn't paying attention. I was too focused writing.
Alright, so as I was saying, geometric mean, we use the geometric mean the same way we would use the arithmetic mean, and that's to find the missing term in between two other terms. So it's sort of like a term sandwich. And we want to know what is the meat in our term sandwich. You can see the formula that we use. We use the square root of x times y. So it's It is as straightforward as it seems until the very end of the problem when there's a twist. So here, we substitute the values that we know into the formula. So it's the square root of 48 times 3. 48 times 3 is, anybody? 144. Very good. Okay, now here's the twist. In an arithmetic sequence, we had one answer. But because we're taking the square root of a number, how many answers are we going to
Two,
get?
positive or negative?
We're going to get 2 answers. So my answer is always going to be
Plus or minus.
plus or minus whatever the value is. Now, if on a quiz you don't put plus or minus, you're only getting half credit because we don't have enough information to know whether this is a positive value or this is a negative value. So we have, the question doesn't ask what is the geometric mean. The question actually asks you what are the possible values of the geometric mean. So it could be a plus, it could be a minus. So just be careful on that. Please don't fall into the trap. Say, oh, the square root of 144 is 12. This is easy. Just please make sure that if it's the geometric mean, the answer is both positive and negative. Okay, does anybody have any questions?